we were also talking offline about the different processes or the different ways in which manufacturing has evolved these days, right? And we were speaking about how extended reality is something that we are using within manufacturing.
Right, right.
And the cases of VR that I've seen at this point is primarily around gaming experiences and stuff. And I was very curious when you mentioned, okay, we are using reality for manufacturing.
Yes.
What kind of manufacturing?
Okay. So to give a clear context about to the audience who is seeing this, okay, a lot of people have this, I should say, a small misunderstanding about what virtual reality, extended reality, augmented reality, metaverse. Now these are terms which have been commonly
Very
used,
loosely
very loosely used
framed, yeah.
these days. So in order to answer that, I'd like to start from the industry 4.0 versus 5.0. 4.0, I told you that it is all about smart systems. 5.0 is about intelligent systems. So to give a clear distinction about how this comes there, as a human being, we have a lot of collaboration with machines or computers in that say. So that's where the whole domain of human computer interaction or man machine collaboration comes into play. After 2000, this has gone to an exponential peak. Okay, so this man machine collaboration, so as a man, I am living in my own real world, right? Machine is living in its own world, right? In its processor, in its memory, it is there, right? What man tried first in industry 4.0 is to bring machine into the man world. An example is robotics. Robot is something that man tried where a machine can live in the man world where humans are living, right? So that is the first case, right? That's what is currently being done, where robots are brought into the industry and manufacturing processes to automate a lot of things, where the machine has come into the man world, right? Whereas extended reality is about man going into the machine world.
Okay.
Okay, you have to take this understanding like this. If a machine comes into the man world, that's currently going on, the robotics, automation, everything. Industry 4.0 is about that.
Okay.
Whereas Industry 5.0 is about a man going into the machine's world. And the example would be extended reality. Right? Extended reality systems are the future for Industry 5.0, which are going to change the whole way in which the things are being done, not just in industry and also in everyday life. So what is this extended reality? Extended reality comprises of actually 4, but right now I'd like to state it as 3. Okay, starting from augmented reality, then comes mixed reality, then comes virtual reality. These 3 together, the common term is called extended reality.
Understood.
Okay, so what does it mean? So you have to take 2 things: objects versus environment. As a human being, the objects that are surrounding me, this is a real object. Do you agree with me?
Correct.
Whatever I'm wearing, this is a real object. This shirt is a real object. I'm a real person. And the world we sit in, right now we are talking, we are in a real world, we are talking with each other. Okay. The environment is real. The object is real. That is our human world, what we live in. Let's say the environment is real, but the object is virtual. Okay. That is augmented reality.
Okay.
Okay. So you will see, let's say, but you need, how do I see that virtual object? You need some device, right? That is where the mobile phones, tablets, computers, all these things comes into play. Let's say I switch on my camera in my mobile phone and I'm recording a particular scenario, right? And whatever there is in the real world is going to be there in my camera. That's what is a camera is going to record. It's going to record whatever is there in front of me. In addition to that, let's say suddenly a virtual object, a virtual some animal pops up. Right, you might heard about this game Pokemon Go, which became recently very popular, right? Where human, opens his camera, moves around the
and
different places, and a Pokemon pops up. There is no Pokemon in real world, right? That's a virtual object, but overlaid on a real world. That's an example of an augmented reality, right? The next is
so when we say augmented reality, are these Snapchat filters also augmented
exactly
reality?
Snapchat filters, where you have the face mask and different hat. All of them are augmented reality.
Yeah. Okay, understood. Okay.
Next is mixed reality. Mixed reality, where the environment is still real and the object is also virtual, which is as similar as augmented reality, but the difference is, how do I see this? In augmented reality, I use devices as mobile phones and tablets for viewing. Whereas in mixed reality, it is as similar to augmented reality, but the difference is I'll have a headset which I'll wear on my head, where I'll have a transparent screen, which is, we can take this glass as an example, right? I have a transparent screen in front of me where I'm able to see the real world. In addition to that, let's say there is a heads-up display in this which shows some icons. Hey, your battery is this much, someone is calling you, right? Something like a heads-up display where in a what you see in an Iron Man helmet, no longer it is fictitious. 10 years back when 2010 Iron Man came, it was something very imaginative. But right now it has come into play. And this is what is mixed realities. You're going to see the real world, but there is going to be virtual objects overlaid, but you're going to see it through a headset, something similar to an eyeglass, but in a bigger scale actually. Whereas the third thing is virtual reality, where the environment is also virtual, where the object is also virtual. You are going to entirely be teleported or transported into a new virtual world, right? Which is created again. It's a computer generated world. So where every object, everything is going to be virtual. That's virtual reality. And these augmented reality, mixed reality, and virtual reality together collectively is called as extended reality system. And the next term is metaverse. Metaverse is nothing but the virtual world and virtual object in a virtual reality scenario is what is called metaverse. It is meta universe, right? So metamorphical universe. So that's metaverse. And that essentially says that a person can get into entirely another universe where they can collaborate with each other, or they can talk to each other. I can talk to someone in America or here, but as if I am being there in a entirely a virtual world. That's a metaverse. And all these collective things put together, these extended reality systems, along with artificial intelligence, along with digital twin, these three words together is going to collectively change Industry 5.0.
Okay. One thing about the digital twin, could you explain that?
Digital twin is something that started from Industry 3.0, right? Where you might have heard the term CAD models, computer aided design models, right?
Is it one of the SolidWorks?
SolidWorks, exactly. Okay. Yeah, it's the same thing. So where you have computer software, right? Where you generate, where you create actually, where you model, in fact, where you model real life products as if it is there in a computer. You'll be able to see it in a monitor. You'll be able to rotate the product and zoom in, zoom out, and see all sort of things in that, do simulations on that. So that's a computer model. Digital twin is almost same. It is a virtual replica of a physical product, but with the intention of having every attribute as similar to a physical product. It is as indistinguishable from a physical product. It should have every property. Let's say I make a ball, a sponge ball in a computer, right? A sponge ball in real world, if I squish it, it has to compress. If I throw it, it will not bounce that much. It will bounce to a level. It should absorb water. And these are properties of a sponge ball in a real world. If I can have all the same properties, not just the looks. CAD model is about the looks, right? Whereas digital twin is, in addition to look, it should also have the property. If I apply force in a computer, within a computer, it should squish as similar to a physical ball, right? If I pour water on it inside a computer, it should absorb the water, right? Every property, that's why the word indistinguishable, right? It should be as similar to a physical product, but it lives within a computer. This is digital twin.
What is the use case of a digital twin, by the way?
Perfect. So in an industry, there are three things, right? So as a lot of things goes on, there are high probability or high chances of getting error, mistakes. Mistakes are something very easily that can occur, right? So that's why they do something called breakdown maintenance, right? Preventive maintenance and predictive maintenance. Breakdown maintenance is something, as long as it works, I'll leave as it is. Only when I encounter a problem, I'll stop the machine and go and check what it is. Like something similar to watches or phones that we use, right? We buy a phone, I'll keep on using it. Only when it is a problem, I'll go to a shop and I'll give for service, right? That's a breakdown maintenance. The second is preventive maintenance. Whether the problem occurs or not, every once in a while, I'll give it to service. Like a bike, it says, okay, every 5,000 kilometers you give for service.
Like a normal vehicle.
Normal vehicles, everything, okay. Right? The third thing is predictive maintenance, right? Continuously, I'll monitor the machine. Let's say I have a motor, an industrial motor, which is running continuously 24/7. All right. I'll have a lot of sensors getting the data. How much RPM it is running, how much heat it is generating, right? What is the flow of coolant into the motor, right? I'll have a lot of sensor gather data, which will be sent to a computer model of the same motor, right? These data, so computer model is already made, which will exactly mimic the motor. So all the equations, it involves a lot of mathematical equations, right? All the equations are predefined, right? Which exactly mimics the behavior of a physical motor, right? That's the digital twin. In addition to that, these sensors data continuously is fed into the digital twin, and that digital twin will say, hey, 10 minutes from now, it is going to break down. Before it actually even occurs, that's predictive maintenance. That's where a digital twin comes into play. Right? One use case I'm telling you. There are other as well.
So probably I could say to measure the threshold of a specific system or a specific object.
I mean,
one use case.
One use case, you can say that.
What could be the other ones?
Other ones is like, let's say, even before a product is actually manufactured. See, manufacture involves a lot of cost. Correct. Right? Getting raw material, you do something. What if it fails after making it? All the money, all the effort, everything goes into waste. I have to throw it down the line, right? So what if I have a computer model which exactly mimics my real model, right? And let's say I make a car. I'm going into this automobile industry again and again.
Go for it.
But yeah. So let's say I take the digital twin of a Hyundai Venue car because that's the one I have. So and I continuously run it for 10,000 kilometers, right? In a real world, I have to actually run it for 10,000 kilometers to even see what will fail, what actually happens, how much things are going to be there, right? Whereas in a digital twin, I can let the computer simulate, right? But it'll exactly tell you what will happen if the actual physical model goes through this particular thing. And it can tell you, hey, after 10,000 kilometers, this is going to fail. After 10,000 kilometers, this is where you have to do servicing and maintenance. So this is a use case of digital twin, actually.
Got it. So, are there any tools or open source softwares that folks can use and experiment with digital twin?
Right now, no. Each and every big industry, Siemens has their own in-house digital twin systems, right? Microsoft has one. Samsung has their own digital twin system, right? But Philips has their own systems. But none of them have come into a common use case, right? Common use cases, you have a CAD model that's open source. There are a lot of softwares are there where you can do simulations are there on that. But that will predict only certain behavior. Let's say I make a pan, right? And I want to know how much temperature it will withstand. Right now, I can make the same pan as a CAD model inside a computer and I can apply heat and I'll see what is the heat distribution. But it won't say what will happen when I give vibration to it. It won't say what will happen when I throw it on my husband. No, that's very difficult to predict for any computer, but so that's where digital twin comes. It encompasses all aspects of science and it exactly predicts the behavior. And to my knowledge, I don't see any physical digital twin that's open source where people can try it right now.
Got it. Okay, so shifting gears again, back to the topic.
Sorry.
I think we
drifted. I'm sorry for that.
Oh, no, that's all me.
Okay.
So with respect to extended reality again, right?
Okay.
How extended reality is currently being used within manufacturing?
Okay. So as I said, extended reality comprises of three things: augmented, mixed, and virtual reality. But to put a disclaimer, mixed reality is no longer going to be a separate domain. It is more and more, it is going to integrate with the virtual reality. In fact, I'd like to show you something as you see. So this is a virtual reality headset, which is the cheapest available in the market, right?
And this from which brand?
This is Oculus Quest 2, right? Right now, after this, Oculus is nothing but the company owned by Facebook. Which is Meta, right? So this is Quest 2 version. After this, Quest 3 has come, and after that, Quest Pro has come. But this is the cheapest version one available in the market. I think roughly 30K in Indian markets. Okay, so it is basically nothing but two monitors in front of me. Okay, there are two small monitors that are here, and there is a computer here, small microprocessor here that does the calculation, and there is a battery here. These are the three components: something to process, which is a computer; something to provide power, which is a battery; and two monitors to display something. In addition to that, there are two lenses similar to my eyeglass, but in a different way. We all know that, let's say I take two mobile phones. I bring closer and closer to my eye. I bring it at a distance of, let's say, 1 centimeter. Will I be able to read anything? No, right? That's because as a human being, we'll have a defined focal length, right? I need the object to be at least at a distance of 25 centimeter for a normal human height to read that properly. Whereas these are two monitors which are going to be brought very close to my eyes, right? But then how do I see objects there? I need some sort of a special lens that helps me see the object in such a way that it is very far from me, right? So there are specialized lenses, optics, which are there here. So this is the essential component of this. Okay, and so this is virtual reality, right? So once you put in, you will no longer be able to see the real world at all. Whatever it is shown on the monitor, it will be as much as perceived by your human senses through your vision. There is audio here, through sound, and there are controllers here, something like this. which will help you to feel the vibration when you touch something in the
How
virtual
strong
object.
is the haptics there?
It's very powerful. It's very powerful. It's like vibration on your mobile phone, even double the time of vibration that you feel on your mobile phone. Okay, vibrotactile feedback that you have, right? So together, these three senses are primarily responsible for human being seeing, hearing, and touching.
Got it.
Are primarily responsible for us to view the world as in 3D, in the reality what we perceive, right? So this is virtual reality. Mixed reality is about, I need the object to be virtual but the world to be real, right? So for that, it is integrated in the same headset, right? If I tap on the side 2 times, it shifts from virtual reality to mixed reality. That's where you see these small dots. These are cameras which captures the real world and projects it onto the monitor. So no longer it will be virtual world, it will be a real world, but still you will have virtual objects. So mixed reality and virtual reality are day by day merging together. So basically there is going to be only two things, augmented reality and virtual reality, because mixed reality sooner is going to merge. So in terms of these two technologies in use case in industry, okay, I'll give you a couple of examples so you understand better. Let's take augmented reality. There is a worker, again I'll go to automobile industry again. Okay, so you purchase a vehicle, right? You're going to leave it for service after a couple of rides, kilometers, or after some few months, right? And that automobile is manufactured by a top manufacturer, Tata, Hyundai, any other top leading manufacturers, right? But the person who actually does the servicing is not from the industry. It is going to be some retailer or supplier who has taken the lease of that particular brand. Okay, how does he know what are the components there? Because so many components are there and everything has to be handled properly. There is an order in which you have to remove the components and you have to attach the component back. You have to see what goes wrong and what goes correct, right? And I do not know, a lot of times they are not trained properly by the people, right? So that they do not know what to do and when to do. This is where augmented reality can help you. Like, let's say an automobile comes for servicing, that particular person has a tablet or a mobile phone, some large thing, right? He shows it onto he switches on the camera on the tablet and he shows the automobile. An on-screen instruction pops up. Hey, this is the engine and there is a bolt here. This is the bolt that you have to remove using this tool. Then he knows, okay, this is the tool I have to pick. Then he can show in front of the camera, hey, is this tool correct? Then it will analyze the tool and say, you have picked the right tool. No, you have picked the wrong tool. It has to be a M20 spanner or something like that, right? Then he goes and changes it. So as a untrained or a half-trained person, he would be able to ensure that things are going properly, right? And everything is being done. So in terms of training a personnel to do the job right, augmented reality can help you very much. Then particularly in quality and inspection. Quality is kind of the most important thing in an industry. Without quality, top brands cannot sell their products at much higher cost, right? So that's where you have to make sure that as a human being, you have to get involved in each and every stage and making sure that my product is correct. It is perfect. There is no wrong in that, right? That's where augmented reality can come again, right? And there is a product that is manufactured. I'll have a app application in my tablet. I open my tablet and I show it in front of the product, and it will analyze the product and saying that, hey, there is a defect here. The product color is good. The shape of the product has come out very well, right? There are a lot of complex computer vision algorithms and geometrical processing going on inside that application to determine all these things. But this can be done using an augmented reality system. Whereas as a virtual reality system, in the early stage, I talked about the product design, right? Where people have to, manufacturing is not a one-man job. A lot of people to come together. But given the current scenario, people are scattered around the world, right? So they need a common workspace where COVID helped us a lot in bringing these virtual meetings, online meetings, right? But still you are distant because you are seeing someone on a computer. It doesn't feel like a face-to-face talk. We could have made this in an online meeting, but it would not have been as what we are currently doing, right? That's where virtual reality can help. You put on the helmet, you entirely go into a new virtual space. A person from America, he puts his virtual reality headset and he also comes into the same space, right? He will see a virtual avatar of you, right? You see the animated movies where they mimic the actor's face and body and everything, right? Those are virtual avatars, right? And those virtual avatars of that person comes into here. You see that virtual avatar and he sees you. And that virtual avatar, right now in the latest headset, they can even pick up your facial expression. When you're smiling, these cameras at the bottom, they'll pick up your facial expression and the virtual avatar will smile. When you blink, it will blink. right? All actions that you do as a human being, as if we are talking face to face, those two virtual avatars will speak in a virtual world, right? I want to make an automobile, right? I have a CAD model which is sitting in a monitor. Instead of that, that CAD model, that virtual model comes into that same space where I can open the door, go and sit inside the car in the virtual world and feel how the product is, right? Where the product, the person and the machine all together in the same space, collaborating with each other. That is another use case of virtual reality in industries.
That's interesting. And okay, I have a very silly question here. What if a person has power? Like, how do you use Oculus?
Okay, so right now this Oculus Quest 2 does not have that corrective lens properties,
Correct.
whereas the latest Oculus Quest 3 and Quest Pro, they have that corrective lenses. So let's say I have minus 0.75, I can set it to minus 0.75.
You can adjust it there?
I can adjust it there so that without need for a glasses, I can directly wear this. So it is there. But right now, I wouldn't say that this will totally conquer the world. As you rightly pointed out, right now they are being used in games and entertainment, not in a full-fledged everyday life. The biggest problem is that our mother used to scold us in our childhood days, right? Don't watch TV too much, your eye will get spoiled, right? That too sitting at a very large, very far away distance. Imagine these two monitors are close to your eyes. What will happen to your eyes, right? So that is a very serious health problems that people are trying to solve using latest display technologies. At the same time, see, I can be in a virtual world. I'm seeing a virtual world. I'm hearing sound from a virtual world. I can even touch object in the virtual world. But my body is in the physical world, right? That has not been transported into the virtual world, due to which we face a problem called motion sickness, right? There are a lot of videos where you can see, in fact, famous would be Richie's plank experience, where a person would be asked to go inside a lift. He'll be taken to the top floor, 10th floor on a building, and there will be a plank floating away from the building. He has to walk on the plank actually. We all know that he is there on a actual room, right? He himself knows that he is on an actual room, but I have tried it out with lots of people. Everyone will be shouting like anything. In fact, after this video, I'll make you try it out. Okay.
That's interesting. Okay, so broadly, if I have to think about extended reality, right? Few things that we discussed is either it could be used for training the personnel, or it could be trained
quality
and assurance
and
collaboration, or maybe to provide a demo sort of thing.
Exactly.
Like I think that's how the interior designing space is also going at, like demoing.
Architecture is the one which is full-fledged right now. They are getting into this VR domain. Imagine you are going to build a house, right? I give you the experience of living in the same house, right? Even before being built. That's where virtual reality is conquering like anything.
Got it. But okay, coming back to the actual assembly line, right? Where can virtual reality be used there?
Right. So in an again I'm going to automobile.
No worries at all. Please
right?
feel free.
So an automobile, that too the top class automobiles, right? Let's say Rolls-Royce, BMW, Audi, right? They do each and every car by hand, right? Okay. That's the quality that they ensure. Right? Each and every parts are being fitted with a human being. They even have a value about how much should I rotate the bolt in every bolt and nut in the thing, right? And that's where virtual reality, right? Let's say a human being is wearing a glasses and it gives them instruction. It gives on-screen display, right? Stating that you have missed this, you have not missed this. There is a checklist, you are doing it properly, right? It even continuously monitors the human health, right? There is a sensor here. It continuously checks how long am I doing it. Am I feeling drowsy during the work, because it might impact the quality of what the person is doing, right? So that's where throughout the assembly line, these kinds of glasses, which is nothing but mixed reality, where the user can put it on and throughout the assembly line, it will guide him towards having a perfect high quality finished product without any, or I shouldn't say any, but very less chances for error.
Got it. So when you say error, first thing that comes to my mind is with the extended reality, two things we'd probably address is, first thing is accuracy of whatever we do, right. And the next one is about the efficiency, right? Yes. Which one do you think has more inclination? Like, why how are we currently using it for both of these purposes, and what is the future?
So currently it is more towards accuracy, not towards efficiency.
Okay.
Right? But industry 5.0, it has to be efficient, because without efficiency, no industry will adopt this, right? So day by day, these headsets are coming into the market. New headsets are coming into the market. In fact, right now I can point around 12 different companies who are competing in this segment. This is going to be a $1 billion segment industry soon, right? So if anyone, for the audience who is watching this, if you are looking for a career in what to do next, please do take this extended reality as your career, right? Extended reality and AI is going to change the industry in a very few years. Not just industry, everyday life as well, right? In fact, I could think of lot of other examples in a everyday life where this virtual reality and augmented reality is going to help me every day.
For example, let's go.
Okay, let's say I have faced this problem a lot of times, right? Due to this new generation scenario, having something like Swiggy, Zomato, right? Ola, a lot of new things that comes into play, where within a place everything will come towards me and I don't have to go in search of anything, right? Let's say I have to buy a new shirt. How do I know it will fit me or not? In Myntra or any other Flipkart or Amazon, I'm buying a shirt, I'm buying any wardrobes, right? A lot of times I buy shoes which doesn't fit me, I have to send it back, right? What if I wear a virtual reality headset and the same shoes, I can wear it and see whether it is fitting me or not properly. I can wear the shirt and see whether is it tight, loose, or according to my need or not, right? So that's one case. Second thing, I go to hotel and a lot of time I get confused about the menu names, right? I don't know what are you even putting in that, right? I do not know. And how will it even look? I do not know, right? That's where I take my mobile phone, I scan the menu, the actual product which is going to be on your table, which is going to come, right? It'll float and it'll say, hey, these are the items is there, this much calories is there, this is how the quantity is going to be, this is how it will look.
You think there's a market for that?
Of course, I believe that's a very serious market for it. In fact, I've seen a couple of videos where it has actually been implemented abroad, but in India, I'm sure it has a very huge market. This is a huge market. Myntra, Flipkart, in fact, Amazon have integrated AR into their application. You open Amazon app in your mobile, you can see, let's say I'm buying this sofa. I want to see how will it look in my augmented reality applications, right? And let's say cooking, these days it's one of the biggest thing, right? A lot of bachelors are staying in Bangalore where they have to take care of their own, right? Where a lot of them might not know cooking actually, right? Where an augmented reality system can say, hey, this is the difference between a mustard seed and this is the difference between a cumin seed, right? And this much quantity you have to put it, right? Rather than watching a YouTube video or explaining, it will actually guide them. I say I wear a glass and it comes up in my heads up display, hey, your burner is too high, minimize it, right? And okay, this is the right time to put the cumin seed, this is the right time to put the onion, right? And it will guide them through creating a perfect food recipe, not just for bachelors, anyone who's looking to learn cooking in a very interactive way, not just watching some YouTube videos and doing that's still there, but this can change the way in which we work, right?
That's very interesting, right? The broader overarching theme that I'm seeing is like everything training or everything learning can eventually be moved to extended reality, just to make it more effective.
In fact, education is a sector where I feel this augmented reality and virtual reality is going to change the whole space. Since you're an engineer, I'll give you as the example. Almost every engineers have gone through this thing in their first semester, no matter what branch you are. There is this course called engineering graphics, right? It requires a lot of you to do spatial thinking, right? Where the professor will be saying, hey, take a cone, take a section, cut it at 30-degree angle to the frustum, right? I mean, what the hell is he even talking about, right? All
Exactly
these things have to, right? I mean, me too, myself too. I have had this problem of visualizing that I have to close my eyes. I have to think, hey, okay, a cone is floating in front of me. I'm taking a section kind of like a knife. Okay, I'm going to cut at 30-degree. Okay, then I'm going from the top. I'm seeing what will it look like. I have to draw that diagram. This is where virtual reality can help, right? You actually can go into virtual reality, take a cone, take a blade, cut it and see, oh, this is how it looked like. Okay, I have drawn something entirely different. That's one example use case, right? A lot of times in mechanical particularly, right, where we won't be allowed to touch very costly machines, because what if the student breaks it? That's a serious thing. But how do I get trained on it if I don't touch it? Right? A lot of times it's also out of safety and fear that someone has to be there, because student might, out of his curiosity, he might touch something where it can cause serious injury. That's where virtual reality can come. I can operate a lathe inside the virtual reality. I can make as many mistakes as I want, but nothing will happen to me. I'll be safe. learning this entire process, not just these days, YouTube has totally revolutionized the way we learn education. A lot of beautiful animation videos, right? And explainer videos, right? But still it is there on a computer, you are outside. What if you go inside and you do it by your own hand? Learn by doing is the best way to learn, right? Not just reading books, not just watching videos. You have to get your hands dirty if you want to learn something new. And what better way to use virtual reality to learn?
But like you mentioned, the only one concern that we are looking, okay, primarily two that I'm looking at this point. First thing is the medical aspect with respect to the eyes, like
Health,
what is the
yes.
degree it would affect your eyes and stuff, or even your mental health to some aspect.
Of course.
But the second one is also about the accessibility to these devices, right? And it's also about the haptics. This is just the headset that we're talking about. If in case you're considering, like, trying on different shoes, or maybe like we mentioned, trying on a lathe machine on your extended reality, which means you need to have a haptic feedback,
Perfect.
right? So that's my next question. How do we make sure that this gap is kind of...
That's where people like us, we come in to do as a researchers, right? I told you about X-ray developer at the start, right? So in 1895, the actual X-ray missions, which helps us to take photograph of our skeletal systems, right? It changed the way medical industry, medicine is being carried out, right? How doctors diagnose a patient, right? And the same way, this X-ray, which I'm talking about, is going to change the way that we live in. X-ray is XRAI. XR is extended reality. Right? The abbreviation of extended reality is written as X and R, extended reality. A, X-ray, not AY, it is AI, artificial intelligence. Extended reality and artificial intelligence together, I would like to call it as X-ray. Okay, in fact, I'd like to take the credit for that. Okay, it's not a term that is available elsewhere. This is a term that I'm coining for myself, where I like to call myself as a X-ray developer, right? I use extended reality and augmented artificial intelligence put together in creating what we call technically as spatial computing systems. Okay, these together forms the spatial computing. Spatial is about providing the 3D-ness environment. Computing is about doing calculations where the artificial intelligence comes into play. Okay, so these together can revolutionize the way that things are being done forward. So in order to answer your question, which is
haptic feedback.
Haptic feedback. Okay. So this is a Quest 2 model which I am showing you. Quest 3 has become 40% shorter, lighter compared to this.
In terms of heaviness?
In terms of heaviness. Okay. Because this is a serious concern, right? See, I put this so much weight in front of my center of gravity is naturally going to shift, which is going to cause my head to lean backward and naturally causing pain in my head and on my side of my heads, right? So, but the latest headsets, right, have become to the size of my eyeglasses, right? There is a company which is making the headsets which are as smaller, not exactly like this, but little bit projecting outwards, like something like a swimming goggles.
Got it.
Right? So that's where the medical issue part of this, and also right now the lenses used in this called Fresnel lenses, right?
Sorry, what is
Fresnel?
it?
But it is written as FRESNEL, but is spelled as Fresnel lenses. Okay, and this is what is there in this, which causes a lot of distortions actually. But the latest one are migrating towards what we call as pancake lenses. Lot to do with physics and things, stuff like that, right? And these are the lenses which helps you to give view the monitor as if you are viewing the 3D world actually. And this is physics and optics is a huge thing that goes into this, and that pancake lenses helps you to reduce the strain that is going on in your eyes actually, right? You can control the brightness, you can, and these as I said, they doesn't have corrective lenses, but the latest headset they have corrective lenses, so you no longer have to wear your eyeglasses, right? You can adjust your power accordingly and you can wear them, so that is taken care of. The second thing is about feeling of touch. See, vibration is not touch. Vibration is giving you a feedback that you have touched something.
Correct.
But the actual touch is about a force, right? When I touch something, a reaction is coming. When I touch this, a reaction is coming up, and that gives us the ability about how hard or how soft the material is.
Correct.
Right? If it is hard, I'll have a huge reaction force, something that is pushing me that tells it, hey, this is a hard material. If I push here, it keeps on going, but I still have a very light thing that is pushing my hands, and I'll feel that this is how it is, right? And there are these controllers which I showed you here. These are currently the one that comes with this headset, which are something similar to a mouse in a computer, which helps you to select, which helps you to navigate within the environment. These only has vibration in them, but research is going in different universities. In fact, our IISc, right, where we have a gloves, right, as similar to the gloves that you are wearing, right, that helps you provide a force feedback, right? The moment I touch something in the virtual object, in the virtual environment, I touch something, a reaction force is put on my fingers, and it tells me that gloves will pull your hand backwards. Right, there are different principles there. Magnetism, with which one they do, pressures is with which they employ this. There are a lot of physics principles, but the base idea is that the moment I touch some virtual object, the gloves pulls my hand backwards. Right, that is the actual force feedback that we get, and that gloves have not come into commercial production, but soon something like that will come. You no longer need your controllers, and there is other way around. Even in the current controller headsets that we have, these controllers are not necessary. Your own hand will act as a virtual hand there, right? I put on the headset and I see my hand, and an outline of my hand is shown as a virtual hand there. The moment I fold my finger, the virtual hand also folds its finger.
Where is the sensor going to come up at that point?
Okay, so what actually happens is that this camera in front, right, they record my hand and creates a virtual hand. The moment I close this, there are computer vision algorithms going on in the background, which tells how much am I folding the hand, and accordingly folds my virtual hand in the virtual reality.
Does it not require for my hand to be in front of the camera all the time?
That's why there are 4 cameras, one at the top, bottom, here and here, right? Okay. It entirely covers your whole body, even it sees your leg, your hand and everything, right? So if you bring your hand to the back, it cannot see. Right?
That's a limitation.
Right? That's a limitation, yes. So where the gloves can actually help you there. Even if you go get your hands behind your back, your gloves are still there, and that can help you if you are touching an object at the back or something like that. Let's say you are in the virtual reality, someone is touching you from the back, right? How do I feel that? Right now there is no means to feel. With the help of this gloves and systems like that, it will help me feel, right? There are these jackets which I have to wear while using virtual reality, and when they touch the jacket, that jacket will put a pressure on my body, which I will feel, hey, someone is touching me in the virtual world. I have to turn back in the virtual world to see who is there in behind me. Those are in the research. None of them have come into full-fledged system. And another important problem with virtual is you need a large space. As I said, you are seeing in a virtual world, you are hearing virtual world, but your body is in a physical world. If you have to walk in a virtual world, you have to actually walk in a physical world. How long? Let's say I want to walk 1 kilometer in a virtual world. Can I walk 1 kilometer in a physical world? Like I can go and dash upon something, right? So that's a limitation. There are some treadmill kind of things that are available. Omni treadmills. Company are manufacturing that. Still now it is not come into with this headsets. In fact, we have developed in our own lab, we have developed a system which helps you to navigate within the virtual reality by staying in a single place. You don't have to essentially walk in the real world, but you have to just stay in the same place, but still you'll be able to walk in the virtual world. We have developed our own product. It's still under patent pending stage. But
okay, so when you talk about force, right, I'm just thinking about if in case I had a glove and if I wanted to experience different textiles. It's a very delicate space because it's like the amount of force is going to be like very minimal, the friction between the fabric and stuff. How is that going to happen?
It's still not there. We have not come to that point actually.
Okay.
Right now the only thing is about migrating from a vibration to a force feedback, right? Okay. Having something to push my hand back, right? To get to the level of as finesse as a human would do, about touching a fur and feeling this hair, breezing over my hands, and the different textile fiber, feeling that silkiness and smoothness,
We're not there yet.
Very difficult. And then again, it is depend on application. Do we need that? And what application does it really warrant that level of finesse in actual haptics, right? You can think of applications in
fashion industry,
clothing industry. It is still there.
But is it absolutely required? Maybe not, but will make the life better. Yes.
Research is going on. Researchers around the world, I'm sure, will come up in the future.
Yeah. I think when we are talking about haptics, one thing that I also wanted to cover is about the prosthetic arms, right?
Yes.
So, is there a way we can mimic what happens in a prosthetic arm? Like, okay, I have one arm which is fully functional and the other arm is like prosthetic, right?
Okay.
When I'm touching an object, will both of them feel the same to me?
Exactly. In fact, our lab, my professor, Professor Dibakasan, he is working in prosthetics, whereas another professor by the name of Professor Pradipta Biswas, he is working on something similar where, controlling something in the real world, but is being manipulated in the virtual world. Right. So these are technologies that are, as I said, but are still under research, have not come into commercial production. When it comes to prosthetic arms, the biggest difficulty for a human being who has lost his arm is about feeling, do I have that arm or not? This is one of the best research that have been done in Harvard, right? Where they have taken a people of 100 different peoples who have lost their limbs, right? The upper limbs or their legs, where they were made to wear a virtual reality headset and they entered a virtual world. See, in a virtual world, I can have my whole body, right? In fact, I can even transform my body. I'm being a male. In a virtual environment, I can become a female, right? I can, right? You can be whomever you want, right? So those people, what they essentially did is that they made them go into the virtual reality and they led inside the virtual reality, they had all their hands and limbs, right? So they had their, let's say for a person who has their upper arm cut, it doesn't mean that he doesn't have any feeling at all. There are nerve endings which stops at the place where it is actually cut, right? There they placed sensors and those sensor data are sent to virtual reality, right? Which are used to manipulate the virtual hand there. So they were trying to hold the object in
The
virtual
signal
world.
still passes, is it?
Still passes. Still passes. That's
Very
human.
interesting.
That's a real world versus virtual world navigation, right? It's a collaboration between real world, taking the data from real world and sending it into the virtual world where you're manipulating a virtual character, where they saw themselves in a mirror, standing with the whole arm body, and where they're trying to move, and actually it is moving in the virtual world, and literally every one of them are crying. And it's a very good video which actually showcased, and they experienced this for 1 hour. And after 1 hour, when asked, they said that I cannot believe that I no longer have an arm right now. I believe that my arm was there for me for 1 hour. This is something that, in a psychological perspective, virtual reality is used by a lot of people for army, PTSD, post-traumatic stress disorder, who are coming from very difficult places, army men, or treated with the help of virtual reality. It has come into practice in psychological domain and mental stress health point of view.
Got it. I think we've covered so much, right?
Right.
And one question that it's like a very broad question, right? What is the ultimate goal of using AR within manufacturing? And if we are going to use that, what is the maintenance going to look like? Or is maintenance still a limitation as to why we are not using it already?
Right. In fact, it's the opposite.
Okay.
See, the two distinctions I told you about is that in Industry 4.0, we brought missions to the man world using the concept of robotics. But that costs like anything. An industrial robot would somewhere cost easily between 30 lakhs to 50 lakhs, right? Which is not feasible for, let's say, small scale industry in Pina, who cannot afford that much of thing to automate their entire whole process, right? Whereas this is exactly opposite of it, where extended reality system, this is 30,000, right? And even further down the line, it's going to come down actually, right? Cheaper. So where a man going into a mission world and monitoring the entire process and checking the quality aspects in everything, right? So testing, reviewing, and collaborating. These are the three main tasks where in industry I feel that virtual reality is going to have a huge changeover, right? You can test the product in virtual product inside the virtual world and see how it would behave in a real world, right? Give the user the experience about how they are going to feel their product. A person who is going to buy a car, so they can literally use the car for hours. They can sit inside their car. They can drive them. They can feel how it's going to be. A person who is going to build a new home or going to buy a new home, right? They can live there for a month and then feel, hey, this wall is hindering me, destroy this wall, But once it is built, you no longer can do that, right? In a virtual world, you can feel, okay, this TV for 10 days it was like this, but if I change it here, I like it much better, right? Those kind of arrangement, interior design, a lot of things can be done in virtual reality, which construction industry is going to change a lot with the help of. In fact, it is being done as we speak, even in India. In terms of everyday any other industries, right? Food industry is going to benefit a lot, education is going to benefit a lot, and the traditional industries that manufactures all the other products, let's say from mobile phones, from t-shirts to pen to car to automobile, everything is going to benefit a lot in terms of three things. One is collaboration during the early stages of manufacturing, during the design phase. Next thing is testing. The next thing is verification and user validation. You have to eventually get customer approval, right? Whether they like the product or not. Rather than making 1,000 products and launching into them, of course, that is still there. I'm not saying it will move away, but the cost and effort involved in making the 1,000 products and actually making the user test it is very high when compared to I make 1,000 virtual copies of the same product, and as the user come into a virtual world and test my product and see how they feel and give their feedback. Right, that's going to significantly reduce my cost of my product. Right now, the cost of the products, every product is very huge due to inflation, due to supply chain management, due to globalization, and the whole world being fighting with each other. Actually, a lot of things are going on, right? That eventually puts a stress in the cost of the product, right? With the help of virtual reality, you can cut down your cost during the entire process, starting from the design stage to the final user validation stage. At different stages, this is going to come in, where you can reduce the cost little by little, which overall accrues to reducing the cost of a car. You can get a car tomorrow for 50,000 when virtual reality is fully applied in an automotive industry, right? So Tata tried it with the Tata Nano, but at the time he did not have virtual reality and things like that, but still he was able to deliver such a product, right? Imagine all the cars getting their cost cut down by at least a 5 lakhs. The major models, 10 lakh car will be 5 lakh, 5 lakh car will be 2 lakh, 2 lakh car will be, let's say, 50,000-60,000.
Is it because we are including all the processes that goes into figuring out, like, okay, this is what the user wants, like testing, marketing?
Exactly. All these pages which requires, in fact, marketing, sales and advertisement consumes cost like anything, right? Bad marketing can totally spoil the product, right? You might have a very good product, but if you do a bad marketing, and if the from a customer standpoint, if he doesn't like the product due to some reason that you have marketed or sold it that way, right, he no longer won't buy it, right? And this virtual reality can help in that, right? Actually feel how the product is, actually test it before actually launching into the market at a very less cost of what, 20,000-30,000.
Interesting. So let's say there's someone who's very much interested into get into this space, extended reality space, right?
Okay.
Few things that you would suggest them to do to get in, first thing, and few things that you would warn them about the space. Because at the end of the day, I think somebody who's investing so much time into figuring out this space of research or entering the industry, and every industry has its own pros and cons, right? Like, what are the pros and cons with respect to someone delving into?
Okay. So in terms of this, I would like to divide the space, whatever you asked, into two things. Okay. Hardware and software. There is hardware, right? How do I create this hardware? Customize this hardware for my own industry, right? Let's say, for example, there is a medium scale industry in Pina who wants this headset, or even a large scale industry who wants to incorporate this headset. Right now, there are around 10 to 12 manufacturers around the whole world who makes this headset, right? Do I have to go to them and bulk order these things? Or can I customize this headset according to my own need within the industry? So you need people who are good in making the hardware for this headset. The second thing is about software. See, this is only the half done, right? Whatever I told about hardware is half. Right? I need software which is running inside the computer here, which will eventually display something on my screen. Like how I use my computer, right? I need a Windows OS. I need Microsoft Word application to even type a letter, right? That kind of software have to be developed. So in that way, anyone who would like to start a journey in this XR space, as a software, in terms of software, I would like to further classify into two things: a designer and a developer. Right? Software development for VR is not that difficult. right? But it like requires some amount of understanding about programming knowledge, right? Certain elements of that, right? But there are a couple of softwares like Unity and Unreal, which are currently being mostly used for developing software for this. As a developer, you need to know how to
Leverage
use the software and create applications. Whereas as a designer, it's a whole new area, right? If you, as a developer, you can only go up to certain point where you develop an application, you deploy it and test it out, right? Whereas as a designer, right, it requires you to understand the theory and mathematics behind this. So in fact, I would like to tell to all the audience who is seeing this, anyone who is interested to get into this space, there are a couple of subjects which I urge you, right? There is no such stream as BE in extended reality, at least until now. In future, it might come up, right? So anyone, let it be from mechanical domain, electronics domain, computers domain, or any other engineering domain, no matter who you are, you have to learn these few subjects. First thing is mathematics, particularly linear algebra, probability and statistics, and calculus. And more importantly, linear algebra, which comprises of that matrix and vectors, matrix multiplication, right? So linear algebra is must because everything is about matrix and vectors inside this extended reality. In fact, AI, we are talking about ChatGPT, right? ChatGPT is nothing, a bunch of a large matrix. In fact, ChatGPT 3.0 version is about 175 billion something, right? It's a very, all those parameters are packed into 27,000 different matrices. So matrix and vectors, I cannot stress the importance of this. So that's first thing that you have to learn. Second thing is you need to learn about geometric modeling, right? Whatever the virtual object I do, I mean, that is going to be viewed in the virtual reality, someone has to create it, right? How do you create a model? What is the theory behind creating a model in a computer? We talk about all these animation movies, animation characters, and all the animations, right? They are done using these geometric modeling techniques. You need to learn about geometric modeling. The next is you need to be good in understanding computer graphics. There is a course called computer graphics. It tells you how a bunch of numbers, because computers understand only numbers, right? Whereas a monitor, you are seeing an image. How are those numbers getting converted into the image that you view on a monitor? That's about computer graphics, right? As a designer, you need to know about linear algebra, geometric modeling, computer graphics, and more importantly, you should be good in programming, right? And the programming language currently being used for these kind of systems are either C++ or C# programming languages. And softwares like Unity are there to help you get started with it. And these are something very important, essential for some most important subjects, but there are other additional ones which will really help you to get started in this field as well. So that's in terms of a designer, software designer. You need to understand all this theory if you are actually getting your own thinking about your own startup in this space, right? If you want to get started right from the scratch, you need to learn all these things. Okay.
Got it. In terms of warnings?
In terms of warnings, the cons of the system, right? See, whatever I told you is kind of like something that we hypothesize, right? 2 years from now, this might happen, right? We didn't expect COVID to happen, but it happened, right? This might be a hype, right? Or it can really go into down, right? Both the things. It can actually take over the entire market, or it can, I won't say it will definitely, I'm sure, in fact, I'm confident that it won't go down, but it might not take over the entire industry as we perceive. But in our everyday life, I'm sure this is going to be there. In fact, it has come up in our everyday life as we are using a lot of augmented reality apps. Virtual reality is still yet to come, given that a lot of cons and disadvantages in that space. But soon, that I think, at least I hypothesize that 2 or 3 years down the line, we'll have a lot of good headsets coming up in the market, which will, the limitation is not in the software. The limitation currently in virtual reality is in the hardware side. So soon that is taken care of, down the line, it should be as a part of our daily life.
Got it. So one question that I was supposed to ask about manufacturing is that how is globalization affecting manufacturing?
Okay.
And what is Indian scenario in terms of manufacturing at the moment?
So with all this technology, we feel we used to, there's this famous saying that the entire world has become a global village, right? So in terms of globalization, another misconception about manufacturing, which I forgot to mention, there was
fifth point
was that people think that a product, let's say this product is conceived, it is happening in a single large industry. No, not at all. This thread alone is manufactured in a separate place. This button is manufactured somewhere. This black color wrapper is manufactured somewhere. The inner electronics inside is manufactured somewhere. The battery is manufactured somewhere. All of them are brought to some other place to assemble. It is brought to some other place to sell. Okay, so any product that you take, let's take a pen for example, as simple as that, it requires a lot of different companies giving, one company has to provide the ink, one company has to provide the refill, one company has to provide thing. So the company who is actually making that will hire other companies, small companies which are smaller than them to make this particular product, and they bring them together and put it and sell the product, right? So in that way, manufacturing is not a single company's job or a single team's job, right? It is diversified all over the world. In fact, the mobile phones that we use, everything, let's say Apple or Samsung, right? Apple is in US, Samsung is in Korea, but the products are made in China, right? But has iPhone quality has come down? No, iPhone is maintaining its quality as similar to that.
How do they ensure that quality assurance?
Exactly. So Chinese, there are both the things. Original iPhone is also made in China. Duplicate iPhone is also made in China, right? The quality is there in the cost, right? What's the cost that you pay for an iPhone? In fact, the one that is recording it right now, right? You have to pay lakhs and lakhs of money, and that's where people who are actually there in Apple, once it is manufactured and it has come to Apple factory, they take time in checking each and every component. Is it as per their design specification? Right? They have given a design to the Chinese manufacturer to manufacture that particular component. That manufacturer has made it and has sent it back to their thing. And the cost of a product depends on quality, right? If every component that comes in is meticulously checked whether it is fulfilling my design requirement, then the cost of the product goes up, right? You can get a same good quality mobile for 10K or 8K. What's the difference between an 8K versus a 1 lakh, right? The components and the quality which the company puts in to verify whether it is as per the design that I have given, whether it actually ensures how long does it work and all these things. So quality is the important part which actually changes the way in which this changes. And particularly for India, in terms of this globalization, so the globalization is about that no longer a product is made in a single country or a single industry, right? It is spread across the world. A lot of different components from different parts of the world come together to a place, they assemble, goes to some other place, and then gets to a lot of different areas for the entire people to use, right? So particularly the technology and advancement has made it in such a way possible that globalization is overall reducing the costs as well. But at the same time, dependence on very few countries for actually manufacturing these systems. Like Chinese is leading the world in manufacturing these kind of components, but that dependence can also kill. That's why Tesla and even Apple are thinking about, even Samsung, they are thinking about moving their manufacturing to elsewhere. And the second best is India. And India is leading, is at least racing towards, leading its race towards semiconductors. Because all these things we talk about, electronics is the major component there. Without electronics, none of these advancements can happen. Artificial intelligence, I need a computer for the artificial intelligence model to run, which means electronics is there. Semiconductors are the one which is the next gold, actually, if I have to put it that way, right? And the current government of India, they are pushing a lot of different measures to start up semiconductor factory. In fact, trivia to everyone who's watching this, I'm not sure if you know, right? There is one company in Taiwan, actually, right, who manufactures almost every electronics that we use these days. The electronics that is in my watch, the electronic systems that is there in that, they have their own trade secret. They won't let it out. And the large machine used by the Taiwan is sold by a London company. In the world, only one company is there to sell that machine. That machine costs millions of dollars, right, for manufacturing the transistors and the microprocessors that we see. A microprocessor has come to a stage where billions of transistors can sit in a microprocessor. How do they make that level of manufacturing possible, right? The machine which is sold by the London company, which is in UK, right, makes that possible, which is sold to Taiwan company. So we are dependent on this Taiwan and London company for our entire electronic system, right? And that dependence can kill us in the long run. So we need to diversify. In fact, the top research institute like IISc, IIT Delhi and IIT Bombay, government is pushing a lot of funds to us to have our own semiconductor facility. In fact, Zogo's Mr. Sridhar Vembu, is having a plan which I recently read in an article of starting his own semiconductor facility in India. I'm sure with the current government and it has to support, because eventually you need the support of a government to get this started. And because of this, large companies like Apple, Samsung, Hyundai, and all these people are looking to set up their industry in India, which will now lead the world in manufacturing.
So when we say semiconductor facility, is it more like a manufacturing standpoint or getting in those?
From a manufacturing standpoint, yeah.
Okay.
Manufacturing, that designing a semiconductor is okay. It can be done, but it's difficult, but still it can be done. But getting it manufactured to that level of accuracy that we are using right now, a chip is hardly the size of my nail, if I have to say, but billions of transistors are there within that nail. How do I place it and make sure the signal processor, it's like a switch on off on off on off, billions of switches, how can I manufacture inside the small scale? That's the trade secret right now that the company TSMC, Taiwan Semiconductor Manufacturing Corporation.
Yes. Interesting. Yes. Oh my god, this was quite interesting.
In fact, the TSMC, they hire from IISc, top institutes like India. They take the good people from here and they're using them there.
That's interesting. So you also spoke about how the funds are flowing into different institutes for this process, right? But is there a chance that IISc is hiring any candidates for internships or?
Okay, so in order for you to get into IISc, so IISc is something different from IITs. Okay, IITs have a bachelor's degree, master's degree, and research programs. Whereas IISc, we are majorly focused on research programs. The second is master's. Very few bachelor's program. In fact, a couple of bachelor program in science and a new bachelor's program, which in fact a lot of people might not know who are watching this can look up, is BTech in mathematics and computing.
Okay.
Right, which talks about whatever I told you, right? Artificial intelligence and the importance of mathematics in that, right? So that's a bachelor's degree which was recently started last year. And in order for you to come into not just IISc or any IITs, right? As we all know, right? For bachelor's you need to write JEE, right? For masters you need GATE exam or UGC NEET exam, NET, not NEET, sorry, JRF or NET, right? But in terms of internships, right? So the best way is a lot of labs in IIScs and IITs, the professors, they call for internship and they post it in their website. So you have to keep constantly monitor. This is something I feel is kind of like lagging, right? There is not a unified portal like with all IITs and IISc where every professor posts their job requirement. In fact, we have jobs for internship, jobs for project assistants. These are temporary jobs, 1 year to 2 year, where you are where you are required to come here, work on a particular projects and stuffs like that. But most of the time, these gets posted in LinkedIn or through the lab's own website, the professor's own website, and things like that. But if you are really interested to come as an intern here, you have to write a mail to the respective professors, okay, telling that this is my interest, I would like to. You have to first search who are all the professors working in that particular domain. You have to apply for internship, and we have a lot of internship. In fact, like we have summer internships for a minimum of 3 months to 6 months, even 1 year internships also, where you can come here and do your final year projects and things like that.
Wow, this was quite interesting, Shankar. Thank you so much.
Sure, thank you.
Is there any question that I have missed out on that with respect to either manufacturing or extended reality?
No, I think we have covered quite a lot, starting from very basics, so to all the things that are there in manufacture, to the latest technology about how the future is going to change in terms of these extended reality systems. One thing I'd like to again point out to the audience, to the younger generation, who are both in their school education and in the early phase of college education. See, no matter what you do, the most important thing is mathematics, right? I cannot stress the importance of mathematics, particularly the technology which we talked about. They are going to depend on 3 important parts of mathematics: linear algebra, probability and statistics, and calculus, right? So please strengthen yourself. In fact, I will also suggest for linear algebra, mathematics is a very boring subject. That's why it's very difficult for everyone, right? But there is a part of mathematics which is this linear algebra, which contains matrices and vectors, which can be very beautifully and intuitively studied. You can have a good visualization for a matrix, what a matrix is. A lot of us, we know that matrix is a bunch of numbers which are put within a square braces, right? Not at all, right? You can have a beautiful geometric visualization about what that matrix does to an object. right? There is a very good book which I recommend people to read if they are interested, is Practical Linear Algebra, a Geometrical Approach by Gerald Farren. This is in fact the one book which made me read again and again, right? Imagine a mathematics book,
Reading it again. Wow.
reading
Yes.
it again and again. It's written in such a beautiful way where you'll get a beautiful intuition about all the matrices and all the vectors, what is happening, what is this geometry all about, right? So I would suggest people to do that and get yourself strengthened in terms of mathematics, and a lot of beautiful explainer videos like 3 Blue 1 Brown and other good YouTube channels are there which they explain the mathematics in a much more interesting way. You no longer have to fear about mathematics and equations or solving them. You can be very happy and in fact enjoyable in learning those things. That's first thing. And second thing is, there was a time when programming was only strapped within the computer science department. No longer. Whether you are a mechanical engineer, electrical engineer, electronics, computer science, biotechnology, no matter what branch you are studying, please start yourself in learning one or the other programming language. I would suggest Python, C++. These are the most important programming language, right? Strengthen yourself in any one of these programming languages because it is one of the most crucial things for these technologies that we talked about.
Absolutely.
Yeah.
Are there any resources like courses that you would suggest for folks?
I mean, so much things are there. For programming, there is no such thing. See,
not specifically programming, like if someone wants to like understand more on the extended reality bit or on that front.
Exactly. So if you want to understand, get a good knowledge about this extended reality system, what is the background? We are right now, we talked about very few things, right?
Correct.
But there are much more deeper insights in terms of, in fact, extended reality combines product design, engineering, mechanical engineering, computer science, electronics, and psychology as well. Right?
Psychology, okay.
Yeah. Because see, whatever I am seeing here, in fact, we call it 3 illusions of VR. Okay, so much more details are there. You please, audience, you can go Google it and you can refer to that, or else it'll become more of a technical talk and they'll cut their video and they'll move on. So, psychology is an important factor as well. So there is a good course in Coursera, right? It's a 5-part course. It starts from the basics of how the virtual reality evolved, right? This is a technology which I have to tell you, it started in 1965.
Interesting.
Right? So in MIT, there was a person, right, who actually laid the foundation of this computer-aided design and all the CAD thing that we are talking about, right? And his MIT, when he was in MIT, he did this work which is called a Sword of Damocles, which is the first virtual reality headset, right? But then again, you need a good hardware to run this and a good software, right? That evolved only very recently. That's why we are hearing this virtual reality term much more recently, even though it was conceived back in 1960s at MIT as well. So Ivan Sutherland, his name is, he's an interesting guy. He's kind of like a inspiration to me for whatever the research work I do. So strengthen yourself for this, and mathematics and programming too essential, no matter what your background knowledge that you're coming from.
Understood. Oh my God, we've covered so much today. It's fully, action packed, and it's like a bullet point. I've been making so much notes. I have to go back and refer to that now.
Sure.
But it was lovely talking to you, Sankar. Thank you so much for taking our time.
Thank you all for watching this. Please subscribe to the Curiosity Project. I mean, when she asked me, it was a really good initiative on getting things down to the very basic level so that any common person can understand. So that I really liked it. Soon more videos are going to come from Pradeepa. So please
performance pressure, but okay. Thank you.
But please subscribe to the channel and keep watching and keep learning, and learn by doing.
Awesome. Thank you so much.
Thank you all.